Okay, so kidney physiology. How are we doing? It can be tricky. There's two different problems that you have to deal with the kidneys and two different negative feedback loops to keep track of. So we're going to attempt to kind of walk through what's happening with those problems. So the first thing to kind of realize is there's two different homeostatic mechanisms that deal with the kidney. The first, the kidney worried about itself. And so what happens is there are little fluctuations of our normal blood pressure. So if you can kind of imagine, so here's like a little graph. So let's say here's our filtration rate, so glomerular filtration rate. And down here is our blood pressure. It makes sense that as blood pressure increases, you're going to filter more. But we can counter that because we don't want to change it. So as long as our blood pressure is in its normal little happy range, so there's this nice little range right here we can be within, and we're not worried about it. And so as we're looking at, okay, if blood pressure is low, that would be a problem. We're going to use our kidney to help blood pressure. Over here, if blood pressure is too high, that would be a problem. We're going to help blood pressure get back to normal. But if you're in this little range and you have a change in blood pressure, but it's not enough to worry about, then what we're going to worry about is this, glomerular filtration rate. We want to have this try to be normal. So as blood pressure goes up, it would increase your glomerular filtration rate. You're going to get more in your sample. But you're still within your normal range of blood pressure, so we're not worried about changing blood pressure. We're worried about the kidney regulating our filtration rate. So in this instance, if blood pressure is going up, but still within its normal box, then our glomerular filtration rate is going to go up. Our kidney's like, yeah, I don't want to filter that much. That's too much. That's not what I usually do. So the kidney's going to do some things that we call autoregulation to lower the glomerular filtration rate. So that's one negative feedback loop. It's something different than if the kidney's trying to help with blood pressure. So let's say we're in normal blood pressure range. Then the problem that we're dealing with is change in glomerular filtration. So GFR homeostasis is what we're interested in. So if you have an increase in blood pressure, you have an increase in GFR. The kidney's going to notice, so we have receptors, remember. So it's going to be dealing with your control center in your kidney. We're going to be dealing with effectors in the kidney to then increase or decrease GFR. That's what we're interested in there. Or it could be the opposite. What if your blood pressure is going down, you're not filtering enough, receptors will notice, the kidney's going to say, hey, we need to filter a little more, increase GFR. Okay, that's in normal blood pressure range. There's a whole section of your notes that dedicate just to that. But where I want to take this video is, then what do we do when we're outside of normal blood pressure? Well, instead of the kidney worrying about itself, instead of the kidney saying, nope, I'm just trying to maintain my normal filtering rate, the kidney's going to say, all right, blood, I'm going to stop worrying about what I care about. I'm going to help you. And in that case, you're going to change your GFR to help with blood pressure. So if our blood pressure is too low, instead of worrying about trying to increase our glomerular filtration rate, we're actually going to try to decrease glomerular filtration rate because we want to keep our water to elevate our blood pressure. That's where this gets tricky. It's because it's the opposite response of what you would expect if it was about GFR. But if blood pressure's off, we care more about that. So the kidney's no longer trying to maintain its filtration rate. The kidney's going to do the opposite of what it actually wants to do to maintain blood pressure. So let's talk about that problem. So now we'll have low blood pressure. So we have blood pressure homeostasis is our goal. So here our problem is that drop in blood pressure. Again, we have receptors. Specifically, baroreceptors are one of them. And we have control center, actually all the way up in the brain, but we have some kidney ones. There's a lot going on here, but we're going to have our control center that are going to send stuff out to effectors. A lot of the signaling will be done with hormones to increase blood pressure. Let's think about some things before we get into the concept map of all of this that could increase our blood pressure. Increase the amount of water that you have. Do things like beat the heart faster. Vasoconstrict, increasing the actual physical squeeze on those blood vessels. These are all things that we're going to want to do. Now, if we want to increase the amount of blood volume, that means we're going to need to get new water from our environment, but also that means that we're going to have to keep the water that we have. And that's where the kidney kind of comes in play. Filter less so you don't pee it out, keep it. All right, so here we go. Let's talk through the kidney and how it's helping with our low blood pressure. So we have our first initial, like we notice, is our problem is drop in blood pressure. Inside of the kidney, the part of the body that recognizes that is the juxtaglomerular apparatus. Remember, that's the part where you have the back end of the nephron, the distal convoluted tubule, talking to the beginning of the nephron, where you have the blood supply coming in to where you get your sample. So it's talking to or connected to afferent and efferent arterioles. So we have a drop in blood pressure, and it's going to be noticed by the juxtaglomerular apparatus. Now, specifically, it's the granular cells that you're using when you're dealing with a problem of a drop in blood pressure. This, if you're kind of looking at our concept map here, the juxtaglomerular apparatus has your receptors and also serves as your control center. It's going to send out a chemical message that in the long run will talk to a lot of different effectors and trigger some other hormones. So that's where we're going next. So the chemical message that you're going to release is renin. Renin is going to be needed to activate something that's already in our blood. So floating around in blood, we have angiotensinogen. Anytime you see gin, that means it's inactive. That renin is going to be needed to make it turn into angiotensin 1. Interestingly enough, also inactive. You have to go through 2 steps to activate this one, but it kind of makes sense because your problem is low blood pressure. You don't want to actually kick in the increasing blood pressure mechanisms unless you really mean it. So we have this first step, renin that was released from the granular cells gets the first step to happen. Angiotensinogen turns to angiotensin 1. Then you're going to travel, because remember this is a blood vessel, up towards the lungs. And at the lungs you have angiotensin converting enzyme, we'll just call it ACE. ACE gets the angiotensin 1 to turn into angiotensin 2. Now number 2 is active. And so that's going to be the hormone that's actually going to communicate directly to the effectors. All right, so now let's talk about all the things that angiotensin 2 can do.